yesterday we started covering a little bit about this. Okay, so now the neat thing about this is that it's not anything that's entirely difficult. It's just something that is new. And now the newness of this is this. Now let me go ahead and reset. Oh, hold on. Let me clear this and let me get it right. The nice thing about this is that this section you also could be aided with your calculator. Okay, so it's not going to be entirely just knowing how to do algebra skills and make sure you know exactly how to find lines. It's you're gonna be use of a calculator in this section. Now let me reset this, and now let's talk about our first function. You know how on this one it actually has that f of x over there? That means that's going to be the y for the first three functions. So like the first function, is that one x plus 3? Yes? Oh yeah, be looking at the one that says CW notes. Yeah, bring that one out. It was the very first one y'all picked up. Yeah, it says CW notes, and it actually looks like this one right here, because that's the one we're going to be looking at, this one. Now, a couple of things. Okay, this is going to mean y for all these three y'all see here. So this means y is equal to x plus 3. This means y is equal to 5. And it also means that y is equal to negative x plus 2. Now, oh, they're going to do announcements? Oh, shoot, they are going to get into announcements. Let's see, before they get into that. All right, if I hit graph, I make this line, right? Okay, now, is it possible for me to tell this line? Okay. Man, they're flowing in my Joe. Here, let me pause this. Let me restart this now. Okay. Now, if I was going to ask you what the domain of this function is, what would you all tell me?
Negative infinity to positive infinity.
Yes. Now, can I change it? Well, you know what? The idea here is that we actually have the ability to tell it to only exist in certain places. So, like the first one, I think one of the first restrictions, what was the first restriction on this? It says x is everything that's greater than negative 5. Okay, let me go ahead and type that in, and you're going to see that something's going to happen now. What do you think is going to happen to this line if I put that restriction on there? It's going to start at negative 5, exactly. So I'm going to go ahead and, now what I'm doing is that I'm going to go into the, y'all see how there's a test menu here? Okay, if I hit second test, and you're going to do this, okay, so you may want to go ahead and follow along with me. I'm going to go ahead and say everything x is everything greater than or equal to negative 5, right? Okay, so when I do this, I'm going to close the parentheses. I will have a graph that, y'all see how part of the graph doesn't show up anymore? That's because I, in essence, eliminated everything that was below negative 5. And that was everything now greater than negative 5. So, but you know what? That's not the only one. Okay, there's another restriction. We're also going to put down the one that is, we're also going to put in down that it doesn't exist past 1, right? Everything x less than 1. Okay, so let's go ahead and write that down as well. So over here, I'm going to go back. Okay, now inside this menu, okay, inside that test menu that I got back into, okay, y'all see how it says logic over here? Okay, I'm also going to include the and symbol, and I'm going to go ahead and put down x is, let me go back into logic. X is everything less than, was it less than 1, right? X is less than, so I'm going to use number 5 and place the number 1 like this. And once I do that, like once you have it written out like this, look what happens to my graph. Y'all see what occurs? I have a graph that now only exists between the values of 5 and 1, not including 1. So if you bring up your table, you're going to go ahead and see that at 1, it says error because it doesn't exist there. But it exists at 0, 3, at negative 1, 2, everything else. So when you're given these functions, you can use your calculator to bring up the table. Now, it's not necessary to use the calculator because you could have very well done, you could have also, oh, you know, I need my, let me get my little markers and then write this down. Now, so we're going to graph that portion of it. So you need a couple of points. So let's do 0, 3. Now I'm using slope. You can go ahead and do 1, 1, go down 1, go down 1, until I hit -5 on the x value. Y'all see that? And then at here at 1, I'm going to go ahead and put down an open circle. So in essence, I will have a line that looks like drawn like this until that value. Just because you see how it says including -5, the little line underneath it? So it's included, so we're going to put a dot to say it's part of it. So we'll have that. Now the next one is kind of interesting, okay, because this next one is actually going to be, if you want, I'll give you a little time to finish graphing that, because I know some people are still writing it down. Now the only thing I did, okay, was just graph the y-intercept, and then I went down slope, down 1 over 1, down 1 over 1 from there. So, you don't have to always be looking at the calculator if you don't want to go through the tables, but if you're lost, please look at it. Now, let's go ahead and do the other one. Now, this other one is interesting. Now, it's not going to show up on the calculator. So when you do these, it's not going to show up. It's going to show up on the table, but not so much on the calculator. Let me explain. Normally, if I do y equals to 5, which is the next equation that's on there, I normally make a line that looks like that, right? A horizontal line. The interesting portion is this. Here's the interesting fact, that this line, we're going to tell it to exist, the x value to exist only at 1. Okay. Now the reason why that's interesting, because now look what happens to this line. You all see the line right here? Look what happens to it. Do you everybody see? Now you might be wondering what happened right now. Okay. There is something that occurred. And let me show it on the other one. This is what you're going to graph. That line, like if I bring up the table, actually it's right there. You all see how everything else that says error on this line that was 5, except that one point? That means I actually have 1 point that was left. Everything else got cut off. Everything else got removed. So that means that on your graph, you're going to have a solid dot there. That's the only thing that got left from that line. The line that was all the way across only got left with one point of existence, because of the way we had described this domain, x equals 1 right there. So that's kind of interesting. Now let's go ahead and now do the last one. The last one normally would have been y equals, and it's -x. Oops, let me do this way. Okay, -x plus 2. And normally this line will look like this. Just like a line that goes all the way down, right? A negative slope line. But in our case, we're going to tell it, we're going to tell this line, hey, only exists, is it greater than or equals to? Is that greater than or equals to? Just one, yeah, is it? Yeah, okay. So that means it's going to be number 4, greater than or equal to 1. So this line, instead of looking the way it does, is now going to go ahead and look like this. So I have this line that got formed now. Now what I'm going to do when I graph these, you can look at the table. But for me, I find it easier just to do y-intercept. The y-intercept should have been at 2. And then I would have gone down to 1 over 1. So 1 over 1. It doesn't start existing until here. 1 over 1, 1 over 1. So you have this line that starts existing like this. But all I did is use the y-intercept and the slope to figure out where. And I really didn't start drawing until I got down to where it started existing, which was it 1 or 2 where it started existing? Was it 1? Okay, so then that means I needed to draw this here, like that. I missed the point. If it started existing in 1, then that's exactly where the line started existing. Is it included? Oh, so it should have been not included then. Then it is an open circle. So that means that when I did this, it should have just been not greater than or equals to. It should have just been greater than. So let me fix that there. Okay, and then hit graph. And the only reason I did that is to, and let me go back to this one. I'll delete this portion and put it in open circle. There we go. All right, so now this is how the graph really should look like. Now I got an interesting looking graph, don't I? I got these three things, and I have. Now I would like for y'all to. I want you to go ahead and write down what you think the domain of this is, and I'm going to call somebody randomly to tell me what they came up with. Okay, so write something down, and I'll call somebody randomly. Okay, lovely. Okay. Now, if it doesn't hit on that number, we're going to go to the number that's closest to it. All right, so this one, actually, I don't think we have it until 28. Let me reduce a couple. I think in this class we're up to you. What number are you, Gamma? Are you 23? No, you're 25. You're 25. Okay, so we'll change it out to 25 being the highest. All right, let's go ahead and generate. Okay, number 4. It's going to be right here, Sheldon. Okay, so Sheldon, what'd you come up with? Actually, he's right. Your right answer should have been from -5 to positive infinity. Yeah, so this is the right answer now. -5, you could write it in interval notation like this, or set notation. Like that. Okay? So you could write it either way. Now, go ahead and now come up with, well, the intercepts is kind of easy to see. Does everybody see the intercepts? It was, they're -3, 0. The other intercept is 0, 3. And the last one is 2, 0. Now, the range is kind of interesting. Write down what you think the range is, and I'll call somebody randomly. Katrina Thompson isn't here, right? Everybody else. Okay, good. Let's pick on somebody randomly. It's 16. I think it's. Hold on. Let's find out who the closest one is. Oh, Christian. Oh, this is the wrong period. So actually, it should have been Jonathan, but we'll go ahead and pick either James or Jose. Either one. Y'all can either one speak in this case. Yeah, no, just either one. If y'all either one has the answer, then tell me what you think it is. So -infinity to 5. You know what? You are partially right. You're partially right, and the only reason why it's not till 5. 5 is in part of the answer. Yeah. So don't get me wrong. 5 is part of the answer. The issue lies in here. Okay. When you look at the y values. Okay. When y'all look at the y values. Okay. There is no discontinuity, but y'all see. Is there any y values between 4 and 5? No, right? So I can't say that those are included. That's the reason I can't say up to 5. But 5 is part of the answer because there is an existence at 5, isn't it? There is an existence. It does exist. So how do we write that down? It's written this way. You'll say the range is the number 5, and then you use the symbol for or, So it's going to be 5, or from negative infinity, which we said over here, to 4 not included. And the reason why we're not including 4, because remember we had an open circle there? So not including 4. Now, how does this is set notation. Let's write it in interval notation as well. This is how it looks in set notation. Sometimes you'll find that it's easier to write it in set notation, other times it's interval. If you're going to write down in interval notation, you write down x is equal to 5. Or, you actually use the actual numbers when you write an interval. Negative infinity. Like this. Does everybody see that? So either one means the same thing. But that's exactly what the range looks like on that one. So that's kind of interesting. Now this next one, let's go ahead and let's have you practice on your calculator. Okay, practice. Put this first part in the calculator. Okay, and then I'm going to call somebody randomly to show me the steps on what you did on the board. So put the first one in your calculator. 1 divided by x. With the restriction. Yes. Oh, after the restriction, you hit the divide symbol. And if you want, let me do this first one with you, because I think some people have the same question. Now that I'm actually asking you to type it down, okay. When you do this one, let me clear this one. Second plus 712. Okay. When you hit y equals, I think everybody's pretty good at doing this, right? 1 over x. At this stage, you should have a divide. Okay. And then I'm going to go ahead and write down x. Okay, so is everybody up to this point? Okay. The next menu we're going to get into is that test menu that's in blue. So you're going to hit the second math button. And we're going to click, is it 5? It's less than 0, right? Okay, good. So we're going to hit 5 and then click 0 and just close up the parentheses. Okay. And what's going to happen is that when you graph this one shows actually the graph. Does everybody see this one right here? This one shows the original one. But with that restriction, this side is not going to exist anymore. So when I click graph, if y'all notice, only the left side exists. Okay? See how now this appeared on the other side? So that means that we have this idea here. Okay, good. Now, go ahead and now do the other one in your calculator. Try the other one and see if you get proficient. Oh, if you want, Sheldon, you can grab a calculator if you want. Yeah, go ahead and grab a calculator. Okay, and then once you're done with that, answer the next 3 questions. Once you're done graphing it, answer the next 3 questions. And I'm going to call somebody random to give me the 3 answers. Okay. How do you do which? Oh, you know what? Let me write it down. A lot. That's actually. I would imagine actually. I would say half or more in this class have a hard time graphing that one. So let me do that for y'all too. The question is, how do we do a cube root? Okay, the cube root actually shows up as an exponent. Well, if you do it like this, this is really, the cube root is really 1 divided by 3. Okay, now there is a function in where you could put it in as the cube root symbol, but we want you to start getting used to converting it to an exponent as like a 1/3. Because later on, when we ask you to start working with these together with other x's, it's gonna play in the fact that you know what it means to get the right answer. Does it make sense? You got to be able to do this conversion, or be able to spot it and say this is really what it is as far as an exponent. So now I'm gonna go ahead and do the next step, which is the restriction. X. This one was everything greater than or equals to 1. So then you should have a graph that pretty much looks like this. Was it 0? Oh, yeah, you're right. Yeah, I'll go fix it. Thank you. So I don't have the paper in front of me. I'm kind of going off memory. Hold on. Let me go over there and change it to 0. Okay, 0, graph. Okay, here you go. So this is what you look like. This is what it looks like. Okay, so now you see if you can figure out the domain, intercepts, and range. And I'm going to call on somebody randomly to tell me those three. Okay. Does everybody feel pretty good? Not yet? Okay. No warm fuzzies, right? We have to be able to. Okay, let's take this in parts. We'll do just, I'll call on somebody to try to give me the domain of what they think it is. On 16 again. What did we say? Oh, it could be either one of you two. All right, so what did y'all come up with the domain? Either James or Jose? Because you got selected at 16 again, so the middle one. No, it could be either one. Either Jose or you. If you don't have the answer, it could be, what'd you come up with? Actually, he's right. Yes, that's actually this time. You got it. Yes. In this case, with this graph, the domain, and actually let me draw in myself what it should normally look like. There's two lines that go this way, and then one that kind of shoots off that way. This point there. The domain on this one should have gone from negative infinity to positive infinity x. So you could write like that, or the other way, the other notation. The intercepts, this one, that one's easy because that one's 0, 0. Now, what I'm interested to find out is now think about what you think the range is. I'll call on somebody randomly for that one. Nine. Yeah, that's right. That's absolutely correct. Good. Yeah, it's also negative infinity to positive infinity for the range. So you got negative infinity to a positive infinity. So you have that as well. You also have that as far as the range. And the only reason why is because it goes from way down over here. The discontinuity that might have happened here is actually taken up by this equation. It just goes on forever. There's no discontinuity, basically. It just goes. So we're good with that. All right, exciting. Now let's go into something that just takes it a little bit further. We're now going to do the opposite, the reverse. We're now going to be asked, given the graph, come up with the equations. So the first thing you got to write on your paper is this. This is the first thing that needs to go on your paper. You're going to write f of x, and you're going to write like this little bracket, this big bracket that looks like this. Okay, and the reason being is because we're going to put in 3 separate equations. Because you notice how we have 3 separate lines? Those 3 lines are 3 separate linear lines. Okay, now you start from left to right. And the only reason being is because we also define our domain from left to right, from lowest to highest. Okay, so when I look at the first one, now if you're like absolutely stuck and you don't know what this line is, you can use stat and stat calc. But for my purposes, when I look at this, it's easier for me to look at the y-intercept and slope. Okay, so like when I look at the slope on this, goes from here to here, so up 3 over 1. So I know that my slope is 3x. I need my y-intercept. So if I continue going up 3 over 1, my y-intercept would have hit there, which is at 5. So I'm going to go ahead and place plus 5 on there. So I have the line that's made by there. But we also know we're coming into the understanding that this line doesn't exist everywhere. Where does it exist from? From negative infinity. Y'all see the little arrow that points that way? So it exists from negative infinity up until where? It's x all the way until, now do I include 1? Y'all see the dot on there? The dot means that it's going to be included. And what I mean is the dot of this one. You should have like a solid dot for that one. So for that one, I'm going to use this. I'm going to use that way to write that that's my first function. It exists from negative infinity. Oh, negative 1. Y'all see how I wrote 1, positive 1? Yes, this needs to be fixed. From to negative 1. So now the next line, being a horizontal line, what is the equation for that one? The next one. Just 4, right? Okay. Which means that on here, since this represents y equals for all 3 of them, all you're going to do is write down 4. Because we're saying also now graph y equals 4. And with the same idea to restrict it. This one exists from 1, negative 1, but not including it. So y'all see what I just did right now? Yeah, I didn't put the line because it's not included. And then from there, I'm going to go ahead and go to, I am going to include 3. See how it goes all the way to 3? So I'm going to put 3 there. Okay. Now I'm good. It's after that, let's do the last one. Now again, I'm going to use just slope and y-intercept. If you're really stuck, go ahead and feel free to use stat edit, stat calc. That slope is negative 2 over 3. So negative 2 over 3x, and then up to, I'm going to go backwards to find out where the y-intercept's at. Up 2 over 3, it should have been at 2. Okay. Now what I want you to do is see if you can come up with the correct domain restriction that goes for this equation. Okay, write it down. I'm going to call somebody randomly to tell me what they wrote down. Okay, good. Let's see what the consensus is here. Oh. Yeah, 16. Man, that 16 number is like hot. Okay, it could be right there. Either one, either one could chime in. I think Jose, he's been talking more, but what'd you come up with? Because I know James has been saying it a couple of times already. Or do you want to chime in, James? Okay, what'd you come up with? So, like this. 3 less than x less than a. Yes, exactly. And that actually describes. Now the only reason why there's no lines is because they're open circles. Does everybody see that? So now we've created this. Okay, good. Now let's do the last part of this, which is an application problem. The application problem says that there's a game, and this game works such a way that it says Fun Plaza provides endless entertainment opportunities for patrons, and it's human-sized interactive board games. Patrons pay a fixed rate of $20 for the first 2 hours, and then they pay additional 10 cents a minute for up to 3 hours, and 5 cents a minute for any additional time over 3 hours. The following function is used to compute the overall cost for a patron. It says where X is the amount of time in minutes spent playing at the game of Time Fun Plaza. Compute the cost for each person given the number of minutes of playtime. Now, this first one, y'all see the 80 minutes? Okay, 80 minutes means that This 80 minutes follows this one. Okay, so which means that if I was going to, using that formula, I'll be paying $20 for the 80. Okay. Now, the 120 minutes has you think a little bit more. And the reason being is that when you look at the equations, the 120 shows up more than once. But in effect, it belongs to the first equation as well. Because the second one, you need to be over 120. Does everybody make sense of that? Okay, so that means that this next one, the charge for that will also be $20. Now, the 140 minutes, and I'll change colors. This 140, oh, hold on a second. Well, I didn't want, oh, hold on, this thing's it's starting to think a little bit too much. Because I think it kind of got stuck a little bit. Yeah, it did kind of get stuck. All right, I'm going to give it a little bit of time for it to kind of catch up because it's running slow. See how it's doing that? Okay. All right, so I think it's caught up to me. All right, so 140, that's this one. Now the 140 fits inside this one. Okay. And you see like the 180? The 180 also fits inside that one. So when you figure these out, all you're going to do is use the equation 0.10 times 140 plus 8. And then this one is going to be the same equation with the difference of being x being 180. Y'all see that? So now we're just applying, where does it go, the proper function. Now, I didn't compute the answer because that's like a calculator exercise. I mean, it's not anything difficult. Now the very last one, I'll use the 200 minutes belongs to this equation because now we're talking about anything over 180. So because of that, you're going to use this equation, 0.05 times 200 plus 17. Okay. All right, excellent. All right. Now, does anybody have any questions for me? What I want y'all to do, because we don't really have a whole lot of time to do the activity, because we only got about 15 minutes left. What I want you to do is start working on assignment number 5. We'll do the activity when you come back on Tuesday. We'll work on the activity. So